welcome. Again, it's good to see many of you for a second or third or fourth time or many more times. I just wanted to give you a couple of updates before I introduce tonight's speaker. We still have, although I'm still waiting for the information from our speaker, we have our first ever Gordon scientific lecture that replaces the Marla lecture that some of you may be familiar with. That will be November 6th, but it'll be 4 p.m. You'll get the information through the usual channels. November 15, Mae Jemison just sent me an email saying that she's on for the 15th, but she's busy, so I won't get a title. Mae Jemison was the first female African-American astronaut. Many of you are familiar with her, so we're looking forward to that too. So those are our next two, and I'm working on folks for the spring as well. So as we mentioned last time, this is our anniversary of NASA, 60 years since NASA was formed. It's not been quite as long as that since they were in Houston. We had a space day at the football game, which is this funny game called American football at the weekend. I was there giving a talk to some kids from a Leaf school, and I completely forgot about the game. So I don't know if Rice won or not. I don't know who they were playing, but yay, Rice, right? Okay, good. So I went home to watch Scotland get hammered by Portugal, so that wasn't so good. But this is the anniversary month of NASA, and as you know, we've got a lot of connections with NASA. And a few weeks ago, there was this, you may have seen it, there was this great article in the Houston Chronicle talking about this guy who'd basically been at NASA forever, working in all the programs, was awarded this thing called a Silver Snoopy, which very few of them get handed out. It's just a fantastic, really nice job that was done. And a couple of days later, I got an email from Treasure Wilson, who some of you remember when she used to work at Rice. Said, hey, did you see this really interesting article? And I was sure. She went, well, that's my grandfather. I went, you're kidding me, right? So anyway, she thought it'd be good if I was to sort of circulate the article, and I says, well, let me do one better. It's anniversary of NASA. We always celebrate the astronauts and all these guys, but there are people that make those astronauts look good, and we're kind of lucky to have one of them here tonight. And he's been with NASA, as the title says, for 1 or 2 years. So let me just introduce Victor Murray. So he's from Barbados. You'll probably hear a little bit of that in his accent. And he began his career at the Johnsons and all sorts of interesting things up in Montana, of all places. And he's basically worked in every single major space exploration program since the Apollo days when he went to NASA in ⁸ So he was there for a lot of the major events. If you haven't seen the movie First Man, it's absolutely fantastic. So he was there through the Apollo runs. Apollo 13 he was there. First Space Shuttle he was there. The ISS when it was started and finished was there, and everything in between. And he is still there working on the future as well. And again, he was awarded the Silver Snoopy just last month or earlier this month, commemorating his 50 years in the space program. He is a Master of Public Health from the University of Houston, and has worked for a whole bunch of the famous companies around here, right on the crease of my piece of paper. But Brown and Root Northrop, Lockheed Martin, I used to work with them myself, Jacobs, and then currently with Barrios. So in this particular month, it's a great pleasure to have someone like Mr. Victor Murray here to tell us about his time in the last 5 decades at NASA. Victor, it's all yours. Thank you.
Thank you. Welcome. I am Victor Murray. But I must admit that I am humbled to have been invited to speak to you tonight. I want to thank Dr. Alexander and the RSI for the gracious invitation. I would like this to be an interactive kind of a presentation. Feel free to stop me at any time to ask any questions. My plan is to discuss my role at JSC and to talk about the importance of every person working at JSC and how they play a part in every mission. Okay, I just need to move it. Oh, okay. I'm sorry. So I'm starting with a timeline. As I said, my role, what I call the village, then a wrap-up and question and answers. This was not part of my training. Okay, I was born in Barbados in 1944, which means I'm only 25 years old. And after high school, I came to the United States in 1963 to be with my mom and several of my aunts and uncles. After about 3 weeks in New York, I realized that I need to go somewhere else. So I joined the Air Force. After my time at Lackland, and then I went to Greenville, Mississippi for medical training, and then back to Brooks Air Force Base for pressure suit and pressure systems training. And after that, I was assigned to Edwards Air Force Base, which is the flight test center of the Air Force, where all the new and modified aircraft are tested by test pilots. Most of those test pilots became astronauts. So I got a chance to work with some of those guys, like Joe Engle, before they came to NASA. My career field was aerospace physiology. Aerospace physiology is the method that the Air Force uses to acquaint flying personnel with the hazards of altitude. The major hazard that we tend to worry about is hypoxia. Should the pressure in the cabin fail, then there's certain physiological issues that occur that could cause, if you're a pilot, to wreck the plane. So every flying person had to go through an altitude chamber and experience hypoxia firsthand. The way we did that, we would evacuate the chamber to 40,000 feet, remove their breathing apparatus, give them a clipboard, and have them do a simple task. First, they sign their names, then they'll write 100 on the top of the pad and subtract by 3 until they passed out or got where they were no coherent. That's the symptom of hypoxia. Every individual has a lifetime symptom. So whatever they experience during that process, they would always repeat it if ever they were flying and they were exposed to reduced gravity. About a year after I was at Edwards Air Force Base, we had a budget crunch in the government, and the Army, who was supporting us for our flights and provided the pararescue training in case we had a crash, they would jump in and try to rescue the pilot. We were asked to volunteer from my unit to be jumpers. So I was one of the volunteers. And of course, you know how the military works. You want to volunteer, right? So I went off to Fort Benning, Georgia, and went to jump school and became a parachutist. We came back to Edwards, and then they sent us up to Missoula, Montana, to jump with the smoke jumpers. They had some different techniques for rough terrain jumping, because as you can realize, if you're in a high-performance aircraft, if one press of the afterburner, you could be anywhere in California. Could be in the water, around among tall trees, in the desert, in the forest. So we were given the training that would allow us to go to those areas should we have to rescue one of the crewmen. That training correlated with NASA, the space program. But living in California and having a lot of friends, I wanted to stay in California. And I was holding out for a job at North American, who were building the command and service module for Apollo. But they could not get a budget to to support me. So I took an interim job at DeSoto Chemical, working, they made the paints and detergent for Sears. I just was looking for a job. I went down the list as a former GI, and I didn't go by the job. I just went by the pay. So I scrolled down the list until I found the highest pay, and I took it, and that's what it was. And I was recently married, and my wife, who sits in the back there, she worked nights. So she's off in the day, and this former supervisor in the Air Force wanted me to come to Houston to work for him. And I kept telling him I couldn't make it. But he spoke to her, and when I came home, she worked on me. Within a couple of weeks, we packed up our worldly belongings in a new 1984-86 Volkswagen and flew to Houston. And we've been here ever since. We started to work at JSC for Brown Root Northrop. I don't know if any of you know, but Brown Root is a construction company, and they built JSC. So when JSC was finished, they were looking for a contractor to do the kind of work that I did. And since Brown Root had the ins with the NASA folks, they teamed up with Northrop, and the company was Brown Root Northrop. And I was hired as an altitude test technician for Brown Root Northrop. That coincided with the Apollo program. We had just almost finished the testing of the command and service module in Chamber A in Building 32, and the Lunar Module in Chamber B. And as altitude test technician, we did similar things like I talked about in the Air Force, where we operated the chambers, rescue for the crewmen as they performed in the service module and or the Lunar Module, and that continued. Then we were ready to go to the moon. We worked, everything has to do with practice. It's always amazing the first time a crew shows up and they have to get in the suit. And like everyone else, you need to have that training profile. They're a little apprehensive, and then as they have one or two more practices, they become a lot better. And as the mission gets closer and closer, then they're proficient in everything they do. And the night before, the last flight before Apollo 11, we worked like 21 hours, just making sure all the T's were dotted and the I's were crossed, or vice versa. At that time of night, you're not sure if it's I or T. So we stayed on, and then I went home and turned on the television, black and white, and it was teary-eyed that I saw Armstrong step from the spacecraft. That was very joyful, but wow, is this happening? I couldn't believe it. And you lost it. That was my first of many flights, many activities to do with training of the crew for Apollo flights. Well, when we got our rocks back from the moon, then we had to have a lunar module, the lunar lab had to process the rocks. Half of the crew that worked on that first Apollo 11 mission went over to Building 37, where we received the rocks. And then the other half went over to Building 7, where we did continued training for subsequent flights. I continued doing that activity for Brown Root Northrop until Brown Root thought they had enough of it, and they pulled out, so we were left with Northrop. And after 17 years in that process, our contract came up for bids, and Lockheed Martin won that contract. Then that contract talking past the slides here. So that went on, and then after our flights to the moon, Apollo 17 was the last flight. We then transitioned to the shuttle. But prior to that, we had a plan, and we had what we call SkyLab and Apollo Soyuz. So we worked, same kind of training, different spacecraft. We had to reconfigure the chambers, get the training together. So we successfully did SkyLab. And we did the Russian in space, because we were thinking that at some point we'll work with the Russians. So we got that going. And then here came the shuttle. So we had to change again, and we reconfigured our chambers for the shuttle and did all the training for the crews, both to operate the systems and the equipment for this new mission. The altitude chamber work, as I said earlier, had to do with the pressure of space. We would pull a vacuum on the vessel, and we would simulate the pressure that you experience in space. So all the equipment that we use in space and all the suits that we'd be using for EVA had to do with the altitude chamber work. Zero gravity was simulated in water using neutral buoyancy to simulate the zero gravity so they can do the mechanical part of it. And again, I was asked to volunteer to be a diver. So I volunteered to be a parachutist, and I volunteered now I'm diving. So we did safety diving to support the astronauts in the water at the WEDF, which is building 29 at JSC. It's now the NBL on its own building at Sonny Carter Center. So that took me halfway through the shuttle program. Through school, which when I left Barbados, I had just finished high school. I was always interested in finishing college, and I did part-time college classes, and it was merely to better understand the science and the technology that was involved in the procedures and the manuals that we had to read and the consoles we had to build and the operations we had to do to be better equipped to be efficient in performing the task of taking care of the crewmen. And one of my managers said, well, you have to finish school at some time, so I did. And he said, well, there'll be more doors open for you. So a job came open for safety. I applied, and I happened to know the guy who was in charge, so he hired me. And so I morphed from the diving and the altitude test technician work to safety engineering. It's then that I recognized that we have safety as an important element of space. Even though I was a safety diver, rescue in the Air Force, lock observer in the chambers, I thought that was just a job. I did not focus on safety as a profession at that time. But the individual, in our scheme of thinking, is the most important asset of any job, and especially space, because it takes a village to run space. No matter how insignificant your job may be, whether you're a groundskeeper, janitorial services, a delivery person that brings the supplies around, or you're altitude test technician, an astronaut, an engineer, a manager, a scientist, you play a certain part in making this whole thing work. And if you're not safe, and if we don't keep you healthy, we can't get the job done. And being a safety diver and safety altitude technician, I was doing safety all along, but never looked at it that way. Now I had to be safety for not just the crew, that's one tier of safety. I had to be safety for each employee. And then I had to be the one enforcing the rules. Not only do we have to worry about the safety associated with the crew and the equipment, there are also some agencies out there that are safety for everyone. If you're talking about employee safety, our employees are taken care of, there's OSHA on your back. We talked about this evening about asbestos. Asbestos became an issue. We still had to be part of the entity that took care of that. Environmental, you can't throw stuff down the drain, you have to dispose it appropriately. We had to take care of that also. So it's that family of entities and agencies that ensure that keep us honest to be safe, so we can keep this core person here, the individual, working to take care of us. And that's the kind of activity that I was involved in. Also, when we were talking about the science of working in space, we were talking about the environmental control system that runs the spacecraft. They have to keep it cool, just like at your house, Freon, your car, gas, whatever. Some of these substances are hazardous. So a safety engineer has to ensure that employees who work with these things are not exposed, don't get injured. So we had to train our technician force, our employee force. So I would train, have the classes. Freon 21 was the substance used in the shuttle. And so I would have to create the comfort zone for employees using Freon 21. Any PPE that was required, any controls that were required to make it a safe activity, I took care of that. For space station, they use anhydrous ammonia. Anhydrous ammonia is used in all kinds of places. It's used especially in your stop and goes, and it keeps the drinks cool. But when you come to NASA and the space program, if we were to expose someone to anhydrous ammonia, it's going to hit the news and it's going to be an issue. So we had to ensure that we trained everyone how to handle it properly, to get the right controls in place, warning systems in place, in order to be sure that we don't injure folks and that we can safely train people to do the work and get us to the missions. In addition to having to teach classes, we also had to I'm losing my train, to manage the issues. We had several safety engineers working in different areas, and I became a manager of all the safety engineers. So then I had to write their reviews. I had to impart some of my knowledge and experience with them. And that's just an idea of what I had to do wherever I worked. And JSC has several different directorates. The one I worked mostly in was EC, which was Crew and Thermal System Division. We had to do with the crew and systems that take care of the crew from an environmental and HVAC situation. However, we have guidance and navigation, we have robotics, We have medical, and all of these different directorates have a piece of the puzzle. And the robotics takes care of the docking mechanisms. So for those directorates, there are also hazards involved, equipment damage involved, and we write the hazard analyses for those tests. I was involved in those tests, writing the procedures, reviewing procedures, ensuring that we can provide safety during those activities. As we moved to the space station, it was more of the same, and daily we have requirements in the space station, and we still have to test before we send it up to the space station. We have SpaceX and the Boeing craft that send a cargo up to the station and soon people, and that same level of safety, scrutiny, and performance is required not only for the employee standpoint, but for the systems, make sure the systems are compatible with what we are accustomed to. NASA is a growing and continuing activity. So as we are working on the station, as we worked on Apollo, we were thinking of SkyLab. As we thought of SkyLab, we were thinking of space station. So now we're thinking of space station, we're thinking of above Earth orbit and beyond. And that's where we're looking at Orion. We've already done some drops with the parachuting system for the abort system. We are working on the Orion spacecraft and other pieces of equipment and things that we need to do to be sure that we can work with exploration. We are looking at, we've had a lot of sleep studies because it's going to take at least 9 months to get to Mars. When on the surface of Mars, there are some issues with temperature, and the temperature is the core, unlike the moon. And so those things are still ongoing. So anytime we are testing, we are looking at that, even though we are still looking at the space station. Several weeks ago, when I had a celebration for my 50 years, I was asked the question, when are you going to retire? And my response is, retire. I've been working there 50 years, same job. Where would I go? And so I'm ready to go to Mars. And this is why I was talking about the village. These are all people who make it possible to go to, made it possible to go to the moon. Today I spoke to a lot of young engineers that Dr. Alexander is working with. And I know some of you here have grandkids and maybe great-grandkids. And with our expertise, our youth, and our past experience, I have confidence that we'll get to Mars and sooner than we think. That, my friends.
Ask questions, and so you don't want that. So who's going to be the first one? Thank you.
As soon as you spoke of humans landing on Mars, the first thing that popped into my head is, unlike Earth, no magnetosphere, and so the radiation is going to penetrate to the surface. And even though Mars is further from the sun than Earth, the radiation on the surface will still be lethal. Plus, the 9-month journey that you mentioned, there will be lethal radiation all the way to Mars, and then there will be the 9 months coming home. So, where do we stand in terms of dealing with this, what looks like a showstopper of lethal radiation going to Mars?
I have to premise this by saying I am not, this is my opinion, not, I don't have the ability to deal with that other than from a safety standpoint. They're going to have gateway, which is, and they're doing all kinds of studies on detection systems and shielding, and I'm not sure where they are with that, but we will not go if it's not safe. Does that answer?
Well, I think you're right. I mean, I think that, you know, the radiation is the big deal, and the question is what kind of radiation you're worried about. Galactic cosmic rays are the big problem. Solar particles are more of them, but you can protect with what Victor was saying with the shielding. The galactic cosmic rays are going to be a big problem. And so there's different ways of looking at that and how you might be able to protect the astronauts in flight. There are parts of Mars that has a little bit of a magnetic field in the southern highlands that may actually act as a protection. There's lava tubes that have been discovered on Mars where they might put the habitats in the lava tubes, and so they'd have to find a way of pressurizing it and sealing it and all that sort of thing. But that provides an actual protection. But I think that's the point, right? I mean, is that all of these safety aspects, this is one of the amazing things that, you know, you've covered some of it here, is that, that you might think that it's all about radiation, or you might think it's about surviving launch, but there's all of these other things, you know, that you need the kind of work that's been going on to sort of make sure, not just to necessarily protect them, which I think is a factor for the engineers, but from the point of view of Victor, is making people realize that they have to be protecting, they have to do things properly, and they have to go through that whole process. So I think, yeah.
We have in this environment we have now, anytime we get a lot of equipment, and the first question I ask, how much does it weigh? Is there a laser in it? Is there radiation in there? So those are axioms of any hazard assessment before we let them go anywhere. And that's going to be the hang-up. You're correct. And they're not going to go if they can't solve it.
Scott and Adam. Well, if you don't mind talking this, because there may be people listening.
You had the opportunity to meet a lot of people in your career that were early with NASA. And I imagine the test pilots had a personality all their own when you were out there in that first part. Can you kind of explain what the personalities were like and how they accepted being astronauts, transitioning from test pilots? I've always heard that Yeager didn't think much of it being an astronaut, and that's why he didn't become one.
Oh. The crewmen that I dealt with, and you're right, a lot of them were not as eager as others, but one astronaut that stands out in my mind is Story Musgrave. He was probably the most intelligent astronaut I ever met. He was a surgeon. I mean, and his motto was, if it ain't easy, it shouldn't be done. So he always found an easy way to do everything. As we go through the EVA exercises, he would try to make it easier than the procedure. And they're driven. They're excited about the next steps and the science. And they know how to get involved in the task, and the training conditions them to accept whatever it is. And by the time they're ready to fly, they're sold. I don't know if that answers your question. Did I? Yes, it was. That was Armstrong.
Really?
Yes. Neil Armstrong. Yeah, the question was, which astronaut crashed flying the X-15 and it split in two? It was Neil Armstrong. You know, the X-15 was a rocket plane that landed on skids. And it was dropped from the wing of a B-52 and made it from Tonopah, Nevada, and flew all the way to LA. Well, first it went about 1.6. It went almost 100,000 feet, and then used the trajectory to come back. It went to LA and come back and landed at Edwards. And so I guess he came in too steep and it just broke in half.
Was this before he was chosen as astronaut?
Yes.
That's what I thought.
Yeah.
Because I remember as a child in the 50s hearing about Armstrong and the X-15, and then next thing I know, he's picked to be an astronaut. Winds up on Gemini 8, handles the stuck thruster really well, gets picked for Apollo 11, and as they say, the rest is history.
Well, the rumor goes that we did not want to give the impression that we were a military country, so we didn't want a military person to be the first man on the moon. That's rumors. That's why he was chosen, or one of the reasons.
So there is a general perception, I think, that NASA has become risk averse. So I'm curious how, as someone who has experienced the incredible successes of taking risk, landing a man on the moon, constructing a $100 billion space station, but also working in the safety organization, how you and the safety organization balance that risk of protecting the astronaut with taking necessary risks to do impossible things.
There's always someone higher up. If there's an activity and I determine that that's not safe, I'm going to say so. We cannot be a rubber stamp for anything we do. However, I'm not in charge of everything. So if we have other folks who take a look at what the risks are, and they have all kinds of statistical programs that they look at, and they come up with a sound decision based on that. And I'm not here to refute that. I'm just saying that it's out of my pay grade to say yes to something I don't understand.
Yeah, actually, it's just funny because we just had a seminar from Nancy Curry-Gregg, and she was on the safety board for the Columbia disaster, and it's exactly what she said was, our job is to tell them whether it's safe or not safe. It's up to them whether they take that advice or not, and that's, I guess, it's above everybody's pay grade at that point. But
Right.
and so that's a really, it's one of these things that the culture has. I guess the culture has changed when it comes to that whole safety thing over the time you've been at NASA because of these accidents.
And there is, when we have been successful, we can be complacent, and things change, but you stay in your lane. I stay in my lane, and you do what you're being paid to do. And if that happens, it's My driver is always, how can I go? How would I like to go and tell somebody's mom, kids, or whatever that Johnny's not coming home because I neglected to do something I knew was wrong? And that's my driver. So I'll stick by my guns at my pay grade.
Actually, a somewhat related question. So my assumption would be that when NASA picks some objective or some mission, let's go to Mars, let's go back to the moon, the longer they wait, the safer it gets. Materials get better, technology gets better, understanding gets better. So rewinding then back to the race to the moon, obviously a lot of that timeline was driven by politics, not necessarily materials and safety and that sort of thing. So my question to you as a professional safety engineer, if you remove that political pressure, and I asked you, when was the safe time to go to the moon, when would you have picked?
I would say the time we got there safely and back. That's a cop-out, though. Yeah, I mean, it's, we test, we train, we look at all the perceived risk that we know about, and it's not a one-person decision. And then if we can all agree that everything looks good, we go. But
So
there's always inherent risk. So you have to go at some point.
Let me spin it a different way. If you were going to go to the moon, would you prefer 60s technology, 70s, 80s, 90s? When would you pull the trigger for you?
I think when we went was the best time. And the reason I say that is because the resources were there, the desire was there, everyone was wanting to do that. Now there's a lot of more competing issues, and we don't have the money to do it. Or the money's not there. I don't see it. I mean, but it will cost. We are looking for the Europeans to help us and something else.
So can I ask a personal question? So you're there in the Air Force. You're at Edwards Air Force Base. Like you said, a lot of the folks from there. I'm reading the George Abbey book. I went to see First Man. I'm a sort of a bit of a geek for this stuff. Did you ever think that you wanted to come out of that pilot stuff and become an astronaut yourself? Was that in the discussions at the time when you were there? Because it was round about exactly the right time when these guys were all being picked up. Was that something that interested you?
I was planning to stow away.
Oh, see, then you're going against your own safety principles.
Yeah, because I figured there was no law against it, and if I could sneak on the spacecraft, they couldn't kick me out before they got back. But no, the competition to become an astronaut is tough. These guys are extremely intelligent and talented, and more than I would ever be. So I always dreamed that I was picked up and I went on a flight, but I don't have the capability to do that.
Well, you seem to have done okay. I mean, but was there? I mean, again, I'm just watching this through movies and reading books and stuff. But was there this? Even I mean, you said there's a few astronauts, but there's hundreds of thousands of people that put them there.
Right.
And you're one of them, right? Was there this big thrill about the whole NASA and going to the moon and everything? And I mean, I know the astronauts got their Corvettes and their TV spots, but I mean, was everybody like at the Air Force there? And when were they all? I mean, I know when you got to NASA, everybody's working lockstep to make this happen. But what was the feeling just around in the air?
It was just news, because in the military, and when I was there was a lot of secrecy involved in the job I did, because of altitude, we were involved with the U-2 SR-71, and we would see the, in Popular Science or Popular Mechanics, I don't even know that they still make that magazine is still out. You would see pictures of the SR-71 and the U-2, but we couldn't talk about it. You know, we would see the astronauts, the pilots come out in the suits, and they'll hide the regulators, or you know, they quick go into the chamber. You couldn't see it, but it was still on some publication. But as you had a security clearance, you had to keep quiet about it. So we were not allowed to do more than just, we knew it happened, but we weren't conversant with it. I mean, you know, I would look at TV like Gemini, the first early Apollo flights. It was just news to us because we were in a different place.
A couple more questions, 'cause I want to ask a technical one, but anyone else first? Scott.
Well, the Russians just lost their booster, and it seems to be that's the one way we get people back from space. Do you have any knowledge or comments about what the situation is going to be in the future, or where we are now with having to use the Russian boosters to get to space when they've failed? I mean, how much is there another system to kick in at some point in time?
As far as I know, there's always a Soyuz parked at the space station, and there are 3 astronauts there now, and they can get back to Earth, and they'll leave the space station on its own. But they're investigating this current incident, and hopefully they'll come up with an answer before December. Failing that, we're like 2 years away from SpaceX and the Boeing vehicles to take our people back. So we're kind of stuck if they haven't determined why that happened. I don't know.
Not to the station,
Not yet, I don't
but
think.
they are building that. They are building the space project down there. But they've got the old pad 39A, right? They've got the old pad. That's what they're renting the old pad at Kennedy 39A, where the Saturn V I think launched from. So they've got that. Blue Origin now has a pad at the Cape as well. So you know, we'll launch horizontally from the Houston Spaceport, right? Eventually, that's what we're working on. So I don't know. You mentioned anhydrous ammonia, right? So there was an issue a while back where I guess it was on the station. It was a couple of years ago where I guess it was one of the cooling systems, or there were some systems, and they had to do the spacewalk, and they were worried that there was a leak, and it was ammonia that was obviously it was frozen,
Right, yes.
but it was landing on their suits. So of course they had to sort of make sure, because they don't want to take that into the station.
Right, yes.
So, you know, as you're training and as you're looking at this stuff, do you actually get to also work with the astronauts? Because if they're potentially having to handle a leak of these hazardous materials, do they get the same kind of training? Do you guys train them, or do they get training elsewhere? Or how does that get handled when it comes to that kind of thing? I mean, if it was one of your guys, it would be, you know, in a lab.
Right, yes.
You've got all these protocols. How does that translate to like an astronaut dealing with?
Well, they have other safety committees that meet for flight. It's flight safety.
Okay.
And flight safety would have a litany of controls for anhydrous ammonia and the EVA, or they couldn't go EVA. But it's more extensive than I would give. You know, we can always run.
Last chance, last call for alcohol. Well, listen, I mean, you know, again, I think we give a lot of sway and a lot of credit to the guys who are out there doing the EVAs, and the women who are doing that, and all these folks who we think make up the space program. But one of my favorite artifacts in the Apollo mission control room, if you ever get to walk inside it, is there's a water fountain and there's a mirror from the Apollo 13 flight. And that mirror was put there because it was the people in the control room who did all the work to get those astronauts back. And when they take a drink of water, they see themselves, and it was because of those. And that was a nice thing for the astronauts to do. And so I think it's really, so it's been great for me. I'm sure it's been good for to actually hear somebody who was, you guys, I mean, you don't get a lot of the attention, but the space program wouldn't have happened if it wasn't for people like you making it safe to work, making it the place that it was, so that all these hotshots can get all the credit. So I really appreciate you coming out, Victor, especially this month for the NASA anniversary. And please join me in thanking our speaker.
Thank you.
And of course, I forgot to acknowledge our sponsor, Mr. Arturo Machuca, who's here. So he's missed the last few lectures, so we're really honored to have him. Thank you all. Hopefully we'll see you at our Gordon lecture November 6th. Keep your eye on your email for it. And then again, our next Spaceport lecture is November 15 with Dr. Mae Jemison. Thank you again for coming out tonight. Go Astros.